Okay. Hey everyone in person and everyone online as well. This is the live stream for assignment 1. So assignment 1 only just got released 30 minutes ago-ish. So probably people haven't had a chance to have a look through it yet, but we're going to go through an overview and kind of give some advice about how to get started. So I guess to start out, the whole kind of focus of this assignment is 2D arrays. In particular, 2D arrays of structs and also using enums and stuff. So kind of the theme of this assignment is based on the Pac-Man game. So you're going to be kind of making a little sort of terminal-based game that's kind of based on Pac-Man. So maybe to start with our kind of explanation, there's quite a bit to read through about the structure. So maybe we'll start with just kind of how you get started. So there's some starter code. So similar to labs, you can kind of do 1511 fetch this activity and get the starter code. So let's do that. Let's just do that. 1511, what is it? Fetch activity. CS Pac-Man. Cool. And let's open up the starter code. Okay, hopefully people can see that okay. All right. So probably the main thing to kind of first have a look at when you're looking at the starter code is just having a look at these different structs that you're provided with. So the two kind of main things that you have are the struct tile and then the struct enemy. And then there's also a few enums as well. So the main one to get started with is the struct tile. So essentially this whole game is you will have a 2D array, so a grid, where each kind of element of that array is a struct tile. And so on the tile, you can have, there might be an enemy or not, or there's also a type of entity that's on there as well. So that could be an entity might include something like a fruit that Pac-Man can collect and it has an effect, or it might be something like a dot that Pac-Man can collect to get points, or a power-up that Pac-Man can collect, or a wall that stops Pac-Man from going through it. So all of those kinds of options are here. So kind of throughout the game, you'll be slowly adding these features bit by bit across the different stages. In terms of the provided code that's there, there's two functions that are provided. One which is initialize map, and this is the one that kind of creates the map to start with. So at least gives you some kind of idea of how you would interact with this 2D array of struct tiles. And then there's also another function that prints the map. So you can see in main, there's not really that much there, but there is this map that's been created. So this is how you'd read this is it's a 2-dimensional array with sort of number of rows, number of columns, and each element of the array is a struct tile. Then it just prints the start. So if you're starting your code, you're going to start it in here. And if you want, you might also like to have a look at the initialize map and print map functions. You don't need to understand these, but if you're kind of confused of oh, how would I access a particular thing, you can look at these as well. They might kind of give you some ideas for syntax, but you don't need to understand them, or you don't need to change them as well. All right, so maybe that's the kind of intro to the starter code. But probably before you actually start trying to write the stages, probably the thing that would be most useful is to have a play around with the reference solution. So if you run 1511 CS Pac-Man, you can kind of run the solution that has already been written for the assignment, and you can get a feel for how it's meant to work. So let's do that. So if you're just in the terminal and do 1511 CS Pac-Man. So the first thing is you have to enter where Pac-Man's starting coordinates are. So let's say we want to say Pac-Man is going to start at spot 3, 4, so the third row, the fourth column, starting at 0. We then see that we print the board, and we've got this little happy character here who's our Pac-Man in the sort of third row, starting from 0, fourth column. we can then see we've got this prompt, create the level, and it's like waiting here. So this is like the first kind of main part of the game, which is a loop that's quite similar to some kind of lab exercises that there's like some hints in the assignment of what exercises it's similar to. But the idea is here, this is the sort of level setup part of the program. So this is the part of the program where you're adding features to the map, but the gameplay hasn't started yet. So that's one kind of feature that you're doing. So here, how this works is I might add a feature, like let's say a wall, and I'll put in like the starting coordinates. So I might put in like, it's gonna start at coordinate 1, 1, and it's gonna end at coordinate 1, 5, let's say. And you can see that it then just prompts for more features. So the idea here is you can add as many features as you want to the level. So walls are features you'll add in stage 1, but say there's another feature as well called like an apple that you add in another stage. So let's say I want to add an apple at coordinate like 7, 9, which is like the bottom corner of the map. And then when I'm done adding features, if I use the S symbol, like so if the character S signals that you want to start the game and you've done like scanning in features. So this little particular loop here is actually quite similar to an exercise in last week's lab called count char type. So that one you were kind of scanning things in until you reached a new line. And so here you're scanning things in until you reach an S. So that's a bit of a hint that it's quite similar to that lab exercise, this first loop. So if you're not, that would be a bit of advice if you haven't done that exercise or if you're not too sure about how to get started, would be like maybe having a look at that count char type exercise again, because it's quite similar. So once we've done that, we can then see the board's printed and those features have been added. So you can see now we've got a wall that's kind of like a horizontal wall going across the map. And we've also in this bottom corner got an A to symbolize the apple. And now we've got this other kind of, we see we're prompted for a command. So this is kind of like the second kind of like type of loop that you'll mainly be having in the assignment, which is the gameplay kind of mode. So this is the mode where you get to move around as Pac-Man, maybe like have a couple of commands, check how many points he's earned, things like that. And like you kind of will do that until Pac-Man like wins the game or loses the game. Or someone hits Control D to signal that they're done and they don't want to play the game anymore. So when you're in this kind of gameplay mode, you can kind of like use the WASD commands to move around. So just kind of like a, normal sort of PC game. So let's move Pac-Man around and we can see that we can move him around and he's collecting dots along the way. We can use like a P command to see how many points he's got. So he's got 40 points for the dots he's collected. One thing as well is that when he reaches the edge of the map, if he wants to then move off the map, it wraps around. So like if I press D again to sort of, I'm still going, I'll end up on the other side of the map. So that's like a stage 2 kind of feature. And yeah, and like, so pretty much the game is going to be adding all of these sort of mechanics, like moving Pac-Man, adding the ability to let's say when I collect an apple, you can kind of notice that, so right now there's some sort of squares around me, but if I collect an apple, this sort of area around me has been cleared. So there's kind of some like little effects that happen for different power-ups. So that's pretty much all the little stages correspond to adding like a little feature in the game. And yeah, you can kind of just go through it bit by bit. And then notice that every time I'm adding a command, this enter command thing is being printed. And I'm not going to quite win the game right now, but if I do like Control D, the game stops and we stop there. So this kind of loop is also kind of similar to the count char type one, but it's a little bit different because it has the sort of Control D part. But there's an exercise in this week's labs called CS Calculator that it's very similar to. So yeah, those two are quite good for like getting your head around how these two kinds of loops will work in this assignment. So, but yeah, they're really the main two kind of features here is you have these two kind of modes, the setup mode and the gameplay mode, and your tasks are you're just adding little bits and pieces to the game to kind of make it a bit more interesting as you go along. So yeah, so my advice, yeah, question? Okay, so the question for people on the live stream is, have we learnt everything, all the content you need so far to do this. I'm going to say probably not like everything up to stage 4, but you definitely probably like to get started for stage 1. I think you could get started for stage 1, definitely. And probably when's the next lecture, Rory? Like tomorrow? On Friday?
There was a public holiday yesterday, so the majority of the content you would have needed would have been in that lecture, but Jake's going to release a video tonight that kind of gives you an overview of the stuff you'll need for this, so don't have to worry about waiting until Friday.
Yeah, so in case people didn't hear that, that's just, because of the public holiday, there'll be a video that's like released to replace yesterday's lecture that should give most of the information. But yeah, even then, like you definitely, like stage 1.1, you could do it now. Like it doesn't actually really require anything. You could do it with last week's knowledge. And even stage 1.2, I think you could get started. Like I think people could get started now if they really wanted to. But yeah, you might find doing the later parts quite difficult until you've done an extra 1 or 2 lectures. Okay, so pretty much like my advice for getting started would be like play around with the reference solution a little bit. You don't have to read through the whole assignment at the beginning. You can just read through, sort of work through things bit by bit. There might be things later that you have to kind of sort of slightly refactor things or rework things from earlier parts, but that's kind of like it's still a good skill to practice. So you don't have to sort of get the whole assignment in your head before you start if you don't want to. But if you want to, you're also welcome to do that. So maybe one thing I'll mention before I kind of go into stage-specific things is that there are, like, these are the provided structs, but you're more than welcome to make your own structs as well. One that gets mentioned, like we hint at in stage 2, but you're more than welcome to add it in stage 1, is to make a struct Pac-Man. So, you know, as part of this game, you have to keep track of Pac-Man's row and column, like where he is on the board. So if you want to make a struct Pac-Man to kind of store those variables in, you're more than, like, that's something you might want to do. You're welcome to do that from the start if you want, but it's a hint in stage 2 as it might make your life easier then. So, but yeah, you are allowed to make your own structs. Also, it's very encouraged you make your own functions because that will make it a lot easier as well as you go on and add features if you've kind of got things sort of neat and tidy, if you have to add something and slightly change something you've done earlier. Okay, so now we'll go into maybe stage 1 in a bit more detail. So, all right, let's see, stage 1. Okay, so stage 1.1 is just placing Pac-Man on the board. So if we look at this here, so let's start by just compiling the kind of reference solution. Sorry, compiling the starter code. And we'll see all it does so far is just print welcome to CS Pac-Man. And so we might want to compare that against the reference solution and see that, okay, the one point of difference is that one of them has a printf that says enter the starting coordinates, and then we can type those in. And then after we type them in, the board gets printed out. So that little difference there, that's pretty much stage 1.1. So it's quite short, actually, what you need to do for this stage. I won't like do it right now, but I'll say it's sort of, don't overthink stage 1.1 too much. It's really like maybe 4 or 5 lines long. There's not like that much to do for the very first stage. And it's stuff you really probably would know from last week, like just how to have a printf, how to scan in some variables, and then you will need to call this function printMap. But you can kind of look at how we've got this initialize map function called here for some ideas. So you can kind of see that, you know, if you wanted to add something, like if you want to print out the map, you're going to have something like print map and then the map, and then you'll also need to pass in the Pac-Man row in the column. Yeah, question?
Can you go back to the console for a second?
Yep.
When you type 3, 4, what's that like position relative to? It's not really 3 columns or 4 rows.
It's like starting at 0. So like imagine you're like, yeah, so the question people might have been, for people who are online, is what is 3, 4 relative to? So it's relative to the top left corner, kind of like, you know, if you think of it as a grid and sort of like column 0, row 0, and that's where it is. It's like indexing into that grid. But yeah, good question. So yeah, so stage 1.1, I'd say don't overthink it. It's really like not too much that you have to do to get that working. Stage 1.2 is a little bit more kind of involved because, as I said, that's where the loop part comes into it. So, you know, there's a bit to kind of read through here, but the gist of it is we want to have this loop that goes until we enter the S character, and then we want the ability to have like different kind of commands inside of that. And so, like if they type wall, we then scan in 4 more integers, and so on. And we're going to add to that later. So it's not like we're always going to be adding walls. Sometimes we might be adding like other features that have fewer arguments and stuff. So there's a bit of a hint here that says you might want to start by creating a loop that scans in 1 character repeatedly, and then inside of this loop, you want to find a way to check if this character was entered, and so on. So like maybe some, I don't know, maybe I'll kind of give like a bit of a hint of sort of pseudocode-y kind of like plan for this one. So so something like you want to kind of like scan in a character, and then kind of like while that character is not an S, and then inside of that we want to do some stuff. So we want to see like, okay, while it was not an S, we want to maybe see that like if it was command to add a wall, then we want to like draw the wall. So this might kind of be like, this isn't code, this is some pseudocode, but if I was like planning out stage 1.2, this might be the sort of thing that I would be thinking about and kind of the rough shape of the code that I might end up with. And then kind of at that bottom of that while loop, I might have to have something to, depending on how you do it, you might have to scan in the next character, but it's sort of up to you about exactly how you implement it, but you might want to scan in next character. Like, depends on your approach. Yeah. But yeah, that might be sort of roughly like, if you're struggling with just conceptually how to approach it, the first thing you might want to do is just recreate that loop that scans in a character until someone hits an S and then it stops. That's probably the first thing to try. And then the next thing to try is add on to that to kind of like scan in more arguments afterwards. I think that that's probably the part that most people will maybe find trickiest, is just the like how to get the structure right of the like scanning things. I think that drawing a sort of horizontal line or drawing a vertical line, I think people will probably be okay with kind of working out those things. I think once you work out one, you probably work out the other one. So I think that that's probably going to be all right. But yeah, let me think. Should I go into more of a hint? Yeah. Okay, so what next? Once you've done stage 1.2, stage 1.3 is kind of like, it's quite related to that. So in stage 1.2, you can sort of make assumptions that all the walls we give you are going to be really nice. They're going to be all on the map. They're going to be like coordinates that make sense. They're just going to be horizontal and vertical. But in stage 1.3, we don't give you as many of those assumptions. So you'll have to like check that the wall is either horizontal or vertical. Like you don't have to draw diagonal walls, but you just have to validate that the commands given actually make sense. And you'll have to also handle the fact that a wall could be partially outside of the map. So that kind of, what that looks like is if we looked at the reference solution here. So let's say Pac-Man is on 3.4 again. And let's say we add a wall that goes from like I don't know, it goes from kind of 1.1 all the way up to 1.100, right? So obviously like column 100 is not on the map. There's only like 10 columns. So this is expected if we like do that. It's just expected to kind of run to the edge of the map. So you're just expected to draw the part of the wall that falls inside of the map and ignore the part that's out of bounds. That's really the approach here. And so I guess the hint for stage 1.3 is that you might want to make a function that checks if something is in bounds of the map. So you might want to make a function that you can like give it two coordinates, like a row, like give it a row and a column, and it will tell you, is that in the bounds of the map? If you had that sort of function, it probably means you could add that in as a if statement or something to your stage 1.2 code, and you'd more or less be at the right answer. So yeah, do you want a question? Yeah, okay, so that's a good question. So the question was, do the walls need to wrap around? The answer is no, they don't. So that makes it actually easier for you. Like, you don't have to do some kind of wrapping around maths or anything. You can kind of just like draw the wall and check if it's in the bounds and like stop drawing when you go out of bounds, something along those lines. I think I kind of like, so say, yeah, with this example here, we've gone from like coordinate 1, 1 to coordinate 1, 100, which is like way off the edge, but we haven't wrapped around. So this first bit here, that's still not empty. So we don't have to wrap around or anything when we're drawing walls. We just like, if it's off the grid, we just don't draw it. But yeah, also like notice that off the grid will include like negative things. So like I could do something like, I don't know, like 1, -5 to 1, 5 or something. And, oh wait, I forgot the W, whoops. Okay. Yeah, so if it's like negative kind of in the other, like it doesn't have to be, it could be negative, it could be positive, it just is like something that's off the bounds of the map. You're just meant to draw the part that is in the map. So yeah, so pretty much you might want to make a function that checks if a row and col is in the bounds of the map. Okay. And I guess like maybe a bit of advice for that is like if you're, because like maybe if it's quite a, you know, a lot of you, maybe you haven't written a function before, and so maybe it seems like something that could be a bit daunting or like you're not too sure what to do, and so maybe like, oh, I'll just skip it for now. I would really encourage you like ask for help from like your tutor or like, you know, maybe ask a question on the forum about how, like about functions or something, because I think if you kind of get your head around it in stage 1, it will make the later stages a bit easier, because you'll find it means you can reuse bits of code that you've already solved the problem for. So yeah, I'd really encourage you if you're really not sure what you're doing with functions, just like maybe ask for some help or like try and put a little bit of time into it early. Might make your life easier later on. So yeah, do you have a question?
Can you collaborate with your peers to like solve stuff?
I think the answer is no. Yeah, no, it's an individual assignment, so yeah, sorry, no collaboration with your peers. Yeah. Okay, all right, stage 1.3. Yeah. Okay, and then stage 1.4. Stage 1.4, I think, is not actually too bad. I think people will might even find it easier than stage 1.2 or 1.3, because at that point you probably got the feel for some of the assignment. So my advice for stage 1.4 is probably just like, what it's essentially asking you to do is go through the whole map and maybe add some things to it. So there's already this function called initialize map, which kind of goes through the whole map and does some things to the map. So like you can kind of look at that for inspiration maybe for like, this is not going to be something you can just take exactly as it is, but there's definitely some aspects of this, like these kinds of two loops inside of each other and stuff that is going to be applicable for stage 1.4. Yeah, question?
Can you be given walls that are like 2D?
Sorry?
Like can you be given like walls
Oh,
that are
yeah,
2D?
okay. So the question was, will you get walls that are 2D? So I'm going to say that you're kind of asking like a diagonal wall, right? Like a wall that's, yeah, so no, like you'll pretty much get a wall that's either a horizontal line or a vertical line. If you, in stage 1.3, if you give it coordinates of a wall that's like, let's say diagonal, so let's say we're going to make a wall that goes from 0, 0 to like 5, 5. Oh, I forgot the W again. 0, 0 to 5, 5. So that would be like a diagonal down wall. Like you're not meant to place that wall. You're just meant to say it's not horizontal or vertical and just not ignore it. Yep.
Can you assume that the wall is going to be like the left-hand coordinate to the right-hand?
Oh yes, you can. You can do that. So the question was, yeah, can you assume that the like, essentially you won't be given backwards coordinates? And like, yes, you can. They will. I think that's still an assumption that is there under stage 1.3. So you can assume that. So yeah, that one you don't have to like draw backwards walls.
That was what I was asking. I'm saying that.
Oh, they are wrapping the other way around. Okay. So.
If you started one here to be able to.
Yeah, okay, no, yeah. So pretty much, yeah, it's you know, not too mean in the sense that, yeah, you'll always kind of get a wall where you're moving like left to right or like top to bottom. I mean, I guess pay attention here that a wall could be just a square, right? Like you could have a wall that's just from like itself to itself, and that's just a block, like a single block. And that's a valid wall. So, yeah, so that's like stage 1. So yeah, I'll write a note for stage 1.4. Okay, and then, oh yeah, I guess as well, there's auto tests for each like stage and sub-stage. So like every time you've done like stage 1.1 or, you know, anything, like you can auto test that particular sub-stage. And then at the very end of like stage 1, you can test the whole of stage 1 together. As you go through the assignment, there'll be like less and less auto tests for the stages. So stage 1, like we'll pretty much, you know, we're not going to be too mean in like the marking of it. Like it's quite thorough, the tests we give you. But definitely like stage 4, there's not that many tests that are written already, and like there's more tests than that in marking. So if you're going to do like stage 3 and stage 4, you definitely have to do your own testing as well. Even in stage 2, like not every, like maybe there's 1 or 2 things that are not fully tested. So make sure you do your own kind of like testing. Doing your own testing is as simple as just running the program yourself and just trying to think of, oh, what would happen in this case? Try it in the reference solution, try it in yours, see that they do the same thing, you're good, that's it. So, yeah. Stage 2, yeah, okay. I probably won't really go into stage 2 that much. Other than just that, yeah, like the main fundamental thing is that there are 2 kinds of loops going on. So there's the setup loop, the game loop. You'll want to like, you know, have the setup loop first, and then after that you have the game loop. And the game loop is what you start in 2.1. And probably by that point you might find it like okay, because you've already done the other loop, so it's kind of similar. But you'll want to like, the later stages will sort of be adding to both of those loops. So when you add a feature, you'll probably add something to your setup loop, and you'll also add something to your game logic. So you'll kind of add it to both areas. Yeah, so stage 2, placing apples, yeah. What else is there? Stage 3, yeah. So if you're like someone who's really, really keen and you know you're gonna want to do like stage 4 and you want to do like the whole assignment, you're welcome to, you might like to read through the whole thing first. If you kind of like, I know I'm gonna do the whole thing, go for it, read through the whole thing first. Maybe that'll help you plan things out. But I think most people the approach is just pretty much do a stage at a time. And in terms of like style, so were you gonna talk about style? Or, yeah, okay. I won't really go into style that much, but my advice would just be do it as you go. If you do it as you go, it'll also make fixing up your bugs and stuff easier as you go. So yeah, but Rory will talk a bit more about style as well. Do you reckon we'd go into any more detail about anything? Or? Yeah, okay. Okay, so yeah, so stage 2, adding the game loop. You're adding stuff to move Pac-Man around, and you're adding stuff to like print out his points, and also place the apples and place bananas as well, which have like a certain effect. So yeah, yeah, I love my pictures. Yeah, got the horrible contrast Pac-Man colors, but yeah. So like placing the fruits have a certain effect. Stage 3, you'll be adding like enemies. So the very first thing you do in stage 3 is add some logic to let you win the game. So once you've collected all the dots, you can win the game. The next thing, which is a bit more involved, is adding ghosts. So you can add a ghost to the board. So maybe we'll show what that kind of looks like. So if we add Pac-Man at like 0, 0, and we'll add a ghost. So we'll add a ghost at like, what is it? Maybe like 2, 0. And ghosts also have a direction that they're moving. So you could be like, okay, I'm gonna add a ghost that's moving like right or something. Is that good? Yeah, right seems good. And then every time Pac-Man moves, the ghost will also move. So the ghost will move like as well around the board. And ghost movement kind of like changes. So after they've moved for like 10 moves, they will change direction. And then like after 8 moves, they'll change direction again, and so on. So, but that kind of that behavior is like stage 3. You kind of don't really need to think about it till stage 3. But if you get up to that and you're kind of like, I don't know what's going on, maybe just play around with the reference to get an idea. So that's ghosts. And then there's also power-ups. So Pac-Man can collect a power-up to then catch a ghost. So that changes some things, changes how ghosts move. So that'll be all stage 3. And stage 4, like, we won't spend much time on stage 4, but the first thing is you're adding floors. So you kind of add, like, essentially other levels in the map sort of thing. So the Pac-Man can kind of go up and down stairs. So that one probably like will involve you to sort of change your code from previous stages. So there's this big warning here as well that you give your code. You're allowed to submit the assignment like at any time, and then we just take the latest submission. So like whenever you've done a little bit, any made some significant progress, just submit it. Like it's best to just submit it like all the time. Then we've got the like history of your submissions and stuff. But yeah, definitely like stage 4, you might want to submit just before you start it so that if you accidentally like break things, you can kind of go back to a nice state before you get going. And then yeah, finding a path. So yeah, we won't really talk too much about stage 4. People can spend their time reading into that themselves. But yeah, any other questions, I guess, about the overall like, yeah?
How do you access previous versions?
Okay, so if you go to, I won't actually like go to it, but if you go to submissions, in your, like on the course website, there's then like all the activities you've done, so all the lab exercises, and there's normally this like little, I forget the color of the bubble, maybe it's like yellow or teal? Teal? Okay, yeah, yellow and or teal, and you can click on those, and it will have the auto tests and the submissions, like all of the copies of them that you've done. Question? Yep?
You know how for our weekly stuff, our weekly modules, like you don't have to do the
Yes.
Can you still get full marks just by doing the 2 dots?
That's a great question, but the answer is no, you can't. You have to do like, sorry, sorry about the way I answered that question.
I'm an instruction management student. I don't even do this.
Okay, I guess the question for anyone online who maybe didn't hear was, in the labs we don't have to do the 3 dots to get full marks. Do we have to do the 3 dot to get full marks in this assignment? The answer is yes, you do have to do stage 4 to get full marks in this assignment if you want to. But yeah, I think that like, it's okay to not aim for full marks. Like that's totally fine. Don't like, stress yourself out. Like a HD is not full marks. So I think you can still get a good mark without doing the hardest bits. Yeah, I'll go, go first. Do you want to? Yeah. That's a good question. I think this is at the bottom of the like, kind of, oh, okay, Rory will go into that question of how much each stage is worth. Yeah?
Sorry for being late. So how many marks can you get for doing all the 2 dot stuff?
Okay, Rory will go into that one because there's a, like the assessment scheme, what things are stages are worth. That'll probably answer that question. Same question. I guess anything else that's to do with like the gameplay, like the nature of what you're actually doing, what the task is asking of you, things like that. Sounds like probably not, so cool. Oh yeah?
You get assumptions at the start of each stage. Will any of the assumptions override passing the test?
Yeah, okay, so the question for people online was, do the assumptions at certain stages like override other stages? So it's kind of like a, like if something changes, so if we give you an assumption in stage 1.2, for example, and then we say in stage 1.3 that it's different, that assumption no longer holds. So, but we'll like specify those things. If there's anything that you think, oh, it's really not clear, you can ask on the forum and we'll like clarify it. But yeah, it should be like, if something's changed, it should be quite clear that you can no longer assume this or something.
Will each assumption have all the assumptions for that?
We may not like list them out again, but we'll might say something like, let me think of, so say like in stage 2.3, there's like all these assumptions about apples, and bananas are they're sort of similar, so we can kind of see that these assumptions also apply. So there might be something like that where it's just kind of like a bit of a catch-all statement that says, this is all the same, and this is what's different.
If you're confused, just ask.
Yeah, cool. There you go.
I am the human now. You can go back there if you want. It's got what? Is it following? It's not following. It's not following.
It's just don't move.
Okay, we'll be fine. Yeah, perfect. All right, guys, so I will just go over the last stuff for the assignment, mostly just like the admin related stuff. First of all, don't plagiarize, please. So obviously this is a university assignment. This is an individual project. So don't take code from other people. Don't help each other with writing code. And don't give code to other people as well, because you might get a 0, you might be expelled from the uni, just all of that stuff. Don't plagiarize. If you do need help, we have a lot of stuff in place to help you. Obviously there's the course forum, so go there if you want to ask questions. We also have help sessions. So help sessions are basically, you get a one-on-one with a tutor. They get to help you out with labs or assignments, whatever you need. And if you go to the help sessions page here, you'll see this is a help session running in week 5. There's 2 on Monday, 2 on Tuesday, 3 on Wednesday, so on. So we've got heaps of help sessions if you guys need help. Usually if it's just you're stuck on a stage and you need to get a hint as to what you need to do, come to one of these if you want. Otherwise ask in the forum. But it is always important to not give up straight away. So if you get stuck on a stage for like an hour, don't immediately go to a help session, because a big part of programming is like working out what's wrong, how you need to solve stuff, and often that comes with time. So come to help sessions if you get really stuck, you don't know what to do. Otherwise, try and work it out yourself and ask in the forum. Yeah? Otherwise, moving on from that, yeah, fun plagiarism stuff. Make sure to submit your work as Liz was saying before, just submit it all the time. As soon as you finish like a new substage, just give your work. We store a history of this so you can go back to other versions of your program. Run this command, you should be all good. Then the assessment scheme. So unlike the labs where we don't actually mark your style, assignments will have a style attribute to them. So overall, this assignment's worth 20% of your 1511 mark, and 80% of that mark comes from your actual performance. So if your program outputs the right thing when we give it certain input, and the other 20% comes from style. So style is really important in programming, especially important in this assignment. It's worth 20% of the assignment. Make sure that when you're running your programs, you're always running the 1511 style command. So this is what you would run. This will check your style. We'll see, okay, we needed to do some indentation here. It's fine. I think it's just, it's just because your comments, you're fine, yeah. But always run 1511 style, always be passing it, so that way you're kind of guaranteed to get a high style mark. But it's also good to ask your tutors, especially, whether your style is good or not, because you might be passing all of the style checks, but you might still not have great style. Something really important to do is make functions, okay? Functions is a big part of the style criteria, but it's not something that the style checker will always pick up. So really important to make functions. Back onto the performance marks. So there was questions before about like the 2 dots, 3 dot stuff. Basically, 80% of your mark comes from these. If you complete stage 1, you get 35% for your performance mark. If you complete 1 and 2, you get 65%. 1, 2, and 3, you get 85%, and then all of it is 100% for performance. So even just finishing that first stage, you'll get a pretty decent chunk of the performance mark. And then completing 1 and 2 gets you 65%, which is pretty huge as well. But basically, you'll notice that the further up the stages are, the less they're going to be worth. So it's really important to the earlier stages over the later stages, basically. Any questions on that? Yeah.
What distinguishes if something's completely working?
It's how many tests you pass, basically, for each one. Yeah, auto tests. Yeah. So we'll give you the auto tests, as we said, but there'll also be like hidden tests that we run against your program as well. So it's important to also test your program. Don't just pass all the auto tests and be like, okay, it's all good. Make sure you look for different edge cases. Look at what the reference solution is doing and compare your output to it as well. That's really important too. All right, I think this is almost the last thing. We have a style rubric here. So if you want to get full marks in style, just follow this rubric basically. Easier said than done. But basically, it'll say here how much each thing is worth and how you would achieve full marks for it. So for example, indentation, if you've got consistent indentation throughout, which the style checker will pick up, then you get full marks for this basically. Do you have a question?
Reasonable vertical white space?
Yeah, so vertical white space, does anyone actually know what that is? Yeah, basically. It's just leaving new lines between your code, basically. Vertical white space, it is a bit subjective, so I would just ask your tutor, since they will be marking you anyways. Just don't have like 50 lines of code with no new lines in between them. Try and separate your code out into different chunks, both in functions and with vertical white space. Yep.
How much do you need to comment?
That is a good question. You should always have a header comment, so at the top of your program explaining it, your ZID and all of that. You should also have comments above all your functions explaining what they do. And then in general, the point of comments is you should have them if you need to explain something to whoever's reading it. So you don't need comments all the time, but it is important if you've got a complex loop or a complex if statement, you explain what's going on. But once again, you can ask your tutor as well if they think the comments are good or not, basically. Yeah.
Do we need comments for provider functions?
There should already be comments for them. There's not? Don't worry about that. You don't need comments for them, but we definitely should have provided them, but that's fine. We won't mark you down for not having comments for them. That's fine. Any other questions on style? But once again, I'll note that a lot of marks come from functions themselves. So like function usage is 4 marks out of the 20 style marks. Function naming is also 2 marks itself. And then comments are also related to functions, which is 3 marks. So functions are really, really important. Try to use them as much as you can. Don't avoid them till stage 4 because it'll just lead to a lot of pain. A lot of people do it. I think I did it when I took the course. It was a bad idea. Just use functions throughout if you guys can. Yeah? Cool. And just a last note on the style stuff. We do have a style guide. Yep.
Illegal elements, what are the illegal?
Good question. So I'll go into the style guide first. So if you're unsure about style stuff, go to the style guide. It'll give you a bunch of explanations of what's good style, what's bad style. And then I think, what's an illegal element for us? Go to. If it says, do not use this element, that's an illegal element, basically. But if it's also something like break, minimize use of break statements, if you use break too much, we might mark that as illegal elements, but you would have to use it a lot, basically. Yeah. All right, any other questions on style? Yep.
What about the long if statements?
Long if statements, is that because the style checker gets angry at it? Generally, it's okay, but I would ask your tutor in that case. Because a lot of the time you want to check like if a point is within these two values and then within these two values and then it gets angry at you, but it is realistically okay. I would just ask your tutor or post on the ed forum basically. Yeah.
What's the nested, I don't know if Bill had, what's the nested loop?
I think it was actually in here.
I missed it.
Yeah, so don't go to 5 levels of nesting or more, basically. This is also related to functions, so everything is functions. Okay, so last thing with the assignment is that it is due on the 24th of October, right, at 8 p.m. So that's 3 weeks from today. Today's the 3rd of October. And basically, you can submit it before then. You won't get a penalty. There is a policy at UNSW that you can submit up to 5 days late. If you do so, then we'll just take 5% off each day from the ceiling of your mark. So that means if you're aiming for like a 60% in your assignment and you submit 5 days late, you will still get 60%, assuming that's what your mark would have been. We only take the percentage off of the ceiling of your mark. Is there any questions about that? Because it's kind of confusing, but otherwise it should be okay. No, awesome. So 24th of October is Tuesday, week 7 as well. So you have whole of flex week to work through it as well. Cool. Any other questions, guys? Everyone?
Illegal stuff in lab. Is there anything like that here?
What do you mean?
We kind of straight.
Right. So in terms of using, yeah. Yeah. If there's course content that we don't want you to use for a stage, we will tell you explicitly in that stage. Otherwise, it's okay. Unless it's banned in the style guide, obviously. Yeah. Cool. Any other questions, guys? Any online questions? No. Awesome. All right. Thanks. Oh, yeah. Sorry.
So just curious, so when I went to a help session for the like, weekly modules, they don't like give very much help with the 3-point stuff.
Yep.
Is that going to be the same kind of thing for the whole class, or?
Yes. So stage 4, you will get very, very little help with. We'll give you hints as to what you can do and maybe help you a bit with debugging, but that's all. We won't like work through your code and figure out what's wrong with it, basically. Yeah. Cool. Any other questions? All right. Well, that's the end of the live stream, guys. Thanks for coming in. There's a lot of you, which is awesome. But I will see you guys around then.